In the last video, we took a look at the qualitative relationship among pH, H3O+, pOH, OH-, and we said that if you know one of those things and Kw, you can get all of the other things. And we set up kind of like a flow chart for that, which is very much unnecessary, but if you like that kind of thing, there it is. And we also mentioned a couple of videos ago what it means to be acidic or basic or neutral under general conditions and at 25 degrees Celsius. So we're going to utilize this qualitative information to then do some calculations. And the first thing I want to point out, and this is super important, there's not just one way to do these, so there are many ways / orders to do these. So whatever I do is just an example. So these orders Alright, these orders are one of many orders, and they all work. For this first example, we're given a pH of 4.11 at 25 degrees Celsius. So, hurdle number one, or thing that it's super duper important to watch out for, you're either given a temperature, or you're given a Kw value, or you're given both. So in this particular problem, this is telling us that Kw is 10 to the minus 14th, right? And that also means pKw is 14. Okay, in fact, I'll go 0, 0 there, and this will be 1.0 times 10 to the minus 14th. So how are we going to go about solving this problem? Well, what do we need to find? That stuff. All right, and we've got some pretty clear steps on how to do it, and the most convenient factor is we're given the answer to part A right off the bat, yeah? Part A asks for a pH. Our pH is 4.11. Done. For part B, we're asked for a pOH, and there's a couple ways you can do it. I think the easiest way for us at this point is just to say that pH plus pOH should be Kw, all right? pH plus pOH should be Kw. And I'll just mention, you could use your pH to get an H3O+, to get an OH-, to get a pOH. And that's a lot of times how I do it. But for part B right here, and I'll try and put the work over here so I can put the answer over there, if we have the pH, we can write out pH plus pOH should be, in this case, pKw, which is 14.00, and that is 4.11 plus pOH. So with a little subtraction there, we can get our pOH as 9.89. And I think writing that out was actually more work than doing it, right? So 14 minus your pOH got us that number, or sorry, your pH. So 14 minus 4.11 gives us 9.89. All right, so that is really all it took for that one. For our concentration of H3O+, we can get by undoing that pH equation. 10 to the negative pH gives us H3O+. So 10 to the negative pH is concentration H3O+, and in this case that's 10 to the negative 4.11, and that ends up being 7.8 times 10 to the minus 5th molar. Alright, so 7.8 times 10 to the minus 5th molar H3O+ is our answer. For part C, we're asked to come up with a concentration of OH-. I don't know if I said C or D, but we're doing part D. For part D, we're asked to come up with a concentration of OH-. And again, you could use your pOH, or you could use your H3O+, or plenty of other things, right? If you know your H3O+, which we do, you can use your Kw and that H3O+ to get OH-, right? So in fact, I'll just write that as a little note here. You could say concentration H3O+, OH- should be Kw. And so I get a lot of mileage out of this particular equation. So we've got concentration OH- as Kw over concentration H3O+. H3O plus. So I use this equation quite a bit in solution stoichiometry. I'm not going to use it here because, well, actually I don't even care. Let's use it here. But I'll just mention. Or, I think in this particular case, getting that concentration OH minus, it'd be easy, 10 to the negative pOH, which is, in this case, 10 to the negative 9.89. And we end up with, in this case, 1.3 times 10 to the minus 10 molar. Alright? And actually, that's what you'd get. I'm not going back and doing it. So, 1.3 times 10 to the minus 10th molar OH minus. And take note, we got sig figs, we got a unit, and we've got labels. These are all things that we need to be watching for. And hopefully the ink on these has dried enough that we can pay attention to our sig figs. If you look here, our pH had 2 decimal places, and the corresponding concentration of H3O plus had 2 sig figs. Alright? Our pOH had 2 decimal places, and our corresponding concentration had 2 total sig figs. Alright? Now let's take care of part E. In part E, we need to know if the solution is acidic or basic or neutral. A couple of videos ago, we went into way too much detail on that, but you can look at comparing your pH and your pOH, comparing your H3O plus and your OH minus, and everything else. In this particular case, we can answer this many ways. pH lower than 7 at 25 degrees Celsius, this is acidic. Alright, so this is lower than 7 at 25 degrees Celsius. This is greater than 7 at 25 degrees Celsius. This is greater than 10 to the minus 7th at 25 degrees Celsius. This is less than 10 to the minus 7th at 25 degrees Celsius. This number is less than this number, or you could say this number is bigger than this number. Those are all ways that you could know this is acidic. So hopefully you're taking note at this point that there's not just one way to do these, and you're going to get the same answer regardless. So I'm going to set up our other problem right here, and then the page can look kind of messy. Alright, our second problem here has a subtle difference. It's still the given pH of 4.11, but all of a sudden our temperature has changed. So very often I get questions from my students like, oh, what do I do if it's a different temperature? And the answer is the only thing that changes is your K value. So in this particular case, we don't have a K value of 10 to the 1 times 10 to the minus 14th. We have a value of 5.5 times 10 to the minus 14th. In fact, 5.47, but so we'll say 5.5 times 10 to the minus 14th. And you may be asking where that would come from, and the answer is you'd get it from a table somewhere. All right? You would not have to know that number, you would have to be given that number. And correspondingly, you know that negative log of kW should get you pKW, which in this case is 13.26. A quick note while we're staring at this here, you'll notice that I had 2 sig figs in my expanded number, and I had 2 decimal places in that pKW, the power number. Alright, so how are things going to be different? Well, not very. I mean, we're still given for part A that the pH is 4.11. We can get our pOH as 13.26 minus our 4.11. In fact, I'll write that off to the side. It is still true that pH plus pOH is going to be pKW. And in this case, our pH is 4.11 still, but our pKW is 13.26. So again, the difference, different temperature, different K value, you'd have to get that from a table somewhere. You'd have to be given that value. So if we do 13.26 minus 4.11, we end up with 9.15. So this is our pOH. To get our concentration H3O plus, and I'm not budgeting my space super well here, I would just do 10 to the minus pH. You don't have to, but whatever. So 10 to the minus pH will get us concentration H3O plus. In this case, that is 10 to the minus 4.11, which may look familiar because it's exactly the same as what we had over there, 7.8 times 10 to the minus 5th molar. All right. Had to squeeze it in, sorry about that. And then our concentration OH minus. We've got this way of doing it or this way of doing it. I think I found out that I inadvertently did it that way, so let's do it that way again. We know 10 to the minus pOH is our concentration of OH minus, which is 10 to the minus 9.15, and in this case that is 7.1 times 10 to the minus 10th molar. 7.1, 10 to the minus 10th molar. Now we've got a bunch of information that we could use to determine whether this is acidic, basic, or neutral. And first thing, pH less than pOH. It's got to be acidic. pOH greater than pH, got to be acidic. This number is greater than this number, so it's got to be acidic. And then all those other ways that we had mentioned over there, acidic. And that is our answer for that. I'm going to put a quick box around those. So this was our answer there. This was our answer there. And again, while these values down here and the pOH number were different, that was because it was at a different temperature, but the same process worked. And there's many other ways you could have set that problem up.